There are many different types of reactions, and every single one of them could be placed in different kinds of categories. There are reactions such as double replacement, combustion, redox, single replacement. Today we're going to do a lab based on a single replacement and a redox reaction. This is going to be the reaction between hydrochloric acid and solid magnesium. The equation. This is the equation for the reaction that we're going to do today. We're going to take a magnesium strip, put it in 2 moles of HCl, and it's going to form magnesium chloride and hydrogen gas. The net ionic for the equation is here. You see, a redox reaction does not only involve the shifting of atoms in a reaction, but also the shifting of electrons. In this case, there are reduction and oxidation. In reduction, it's when an atom gains electrons, and oxidation is when an atom loses electrons. So in this case, magnesium is oxidized. Magnesium loses 2 electrons and becomes positive, while hydrogen gains 2 electrons and exhibits reduction. This is a redox reaction, short for oxidation reduction. So now we're going to do a lab. So to set up this experiment, we're going to need HCl and magnesium. We're going to use a logger probe, temperature probe, have it set up to a computer so we can record the change in temperature as it happens. So what we're going to do is we're going to first take our 25 milliliters of HCl. Of course, it's very important to wear glasses because there will be bubbling from the release of a hydrogen gas as you do this. So you enter in our HCl right here. And what we're going to do is we're going to first get the temperature probe in the HCl, allow the temperature to let it sit there for at least a minute, around maybe 30 seconds, to let the temperature stabilize and get used to the temperature that's in there. So what's going to happen is when I put in the magnesium strip, the magnesium solid is going to dissolve and it's going to form magnesium chloride, and hydrogen gas will be released in the redox reaction. It's very important to wear goggles due to the splashing, and gloves are optional due to the working with acids. So now it seems that the temperature has been stabilized at 22.5. So we're going to first let it collect for about 10 seconds before we insert in the magnesium to get a basic temperature for us to work with. So I'm going to press collect. Let it collect for until it gets to around 10. And at 10, I'm going to put in the magnesium strip. Here we go. And it starts to bubble, as you can see. You want to constantly stir as you're doing it and let the magnesium strip dissolve. You want to keep your face away from it, from the hydrogen fumes that are coming up. You want to constantly stir to keep the to allow for to dissolve faster and get a constant reading of the temperature. As you can see, the curve is going up. It shows us that this is a exothermic reaction. You can usually do this for around 3 minutes, but you can just stop when temperatures remain constant for a elongated period of time. It seems that our magnesium has disappeared. It seems like it's all gone. Temperature is beginning to stay stable. It seems to be staying at around 29.7. Alright, temperatures are dropping, so now that temperatures are dropping, I'm going to click stop. And as you can see from our graph, it's a temperature right here was where our we added the magnesium, and when I added it, the temperature got higher. For the purpose of this experiment, we didn't need to really know the weight or grams of magnesium, because we were just trying to see if it was endothermic or exothermic. The energy required to break the bonds is more than the energy required to form new ones. So that's a redox reaction for you. Thank you for listening.